Hello, test one, test two. 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 Hello. Hello. turn it off on my phone. And then we'll just erase this. Vlad, does it say? Oh, I guess if you change screens, it's gonna change on the live stream.
Yeah.
But does it say on YouTube that the quality is poor?
No.
I mean, it looks good on your phone?
Yeah.
Okay. Mic's on, right?
Uh-huh.
Okay. I like the will and the stance. Yeah. The audience. Alright, put this clip on my screen like this.
No, on yourself.
You think I should wear it?
Yeah.
Why do they make it hairy?
So that the yeah.
Diffuse the
so
sound?
Like,
So if I
like,
spit and peas and stuff like that?
Yeah.
You think it's okay in my pocket?
Yeah, here.
Huh, alright. It sags a little bit. Someone want to check X? Any of you have X? See if that's on also. Yeah, I on YouTube I was able to put 0 delay, and then also on OBS I was able to put 1 second delay. But I on X I didn't mess with the
on
set.
YouTube it's 5 seconds.
What? Usually it's the.
No, YouTube is like about 3 or 4 seconds.
Oh, okay, that's fine. I don't think it's a big deal.
Yeah.
It only becomes relevant if people ask questions, but.
Yeah, it's like transcoding and stuff and filtering everything.
Yeah.
Want to make sure.
Yeah, Vlad is gonna make sure if we say any secrets, he's gonna press the the button.
We
The-
don't have that button.
Yeah. Well, you could just turn the mic off. Quickly switch to the mic.
No,
and,
just remove the receiver.
yeah.
It's my kill switch.
Oh, we have a few minutes. We should.
You need to welcome people to the stream.
How do I welcome people? What do the streamers do? They do. Will, you know, you're gonna be like industry plant. You're gonna start like paying money during the stream. Maybe like give a donation of $10,000,
Yes, yes.
and then
Welcome to the stream.
Welcome. welcome. Take your seats.
I mean, it's not gone all the way, but it hit the bottom bar and stuff.
Oh yeah, so it's good. It's like clear.
Yeah, much more clear.
All right. I mean, if anything, we'll figure it out.
Yeah.
This is pretty good.
Yeah.
This is good quality.
You play the music. You need
Oh,
the
okay.
lobby music.
All right, I'll put the music on.
Slap.
Should I, But we're not gonna get like shadow banned on YouTube. Not shadow, or they like delist you. I won't show the. Because they do it with AI, or they just like.
No, they can tell you.
Yeah, so I shouldn't do this.
Please already do it. This is like
Okay, I mean tell us a non-copyright music.
No, they're not gonna get you on the copyright on that one.
Why? Because it's old?
I mean, I feel the quality is just bad.
That's true. Quality. We'll wait another minute or two. Yeah. Oh, what am I supposed to say? You want to come and welcome? Will's the welcomer. Keeps on saying you're welcome. Welcome everybody. Welcome to our webinar. Maybe we give them. We give them a tour of the office while we're waiting. While you guys are waiting, we got a tour of the office. This is our new whiteboard.
Shit.
What happened? There's an issue? Vlad is,
Just turned off the screen.
he turned it off?
No.
Vlad is the streamer. Will's the audience. We have a view outside, beautiful summer day in New York City. Chinmay is also making sure that everything's going all right. Yeah, this is our office.
How do I hide this? How do I hide this?
You hover over it and click the three dots, minimize, and that one. Don't watch.
This is gonna be the stream. This one.
So it's fine.
Okay.
It's good enough.
Do you guys see the right thing?
All right. I guess we'll give another 30 seconds and then start. Is everything? Thank you, Will, for being so supportive. Everything looking okay, Vlad, on the thing?
Mm-hmm.
Okay. Cool. All right, let's give it another 30 seconds and then we'll dive right in. Let's see. Oh, we should post this on LinkedIn. Will, you have access to our LinkedIn? Let me see. Maybe I'll post it real quick on our LinkedIn from my phone. And I'll view as admin. Okay, I'm gonna kick off this post on LinkedIn. Okay, I posted it on LinkedIn. Okay, I think yeah, we could get started. Thank you. We have a live audience. This is filmed in front of a live audience with a laugh track. So okay. So in this webinar or this presentation, I'm going to go over the topic of fine-tuning open source models. We're going to do a few live examples, and hopefully we'll have a pretty actionable, practical conclusion for teams of who are exploring fine-tuning open source models, and hopefully this will be insightful for all those who are tuning in to make a decision of what to do in their production workflows. So the way at least we're thinking about it, there are two types of ways to look at open models. There are the frontier level open source models that we hear a lot about, you know, Kimi K3 and all those other models that come out, a lot of the Chinese model, quote unquote, that are open source. These are frontier models that are massive and are trying to compete with, let's say, a Fable or the GPT Soul, Terra, and all those models that just came out. So those are the frontier side of things. They serve a very specific purpose. They serve a very specific need. We're not going to be focusing on them. What happened?
Some people in the chat are saying your voice is not audible on YouTube.
My voice not audible. Okay, we're having technical difficulties on YouTube.
No, I can hear you.
Oh, you can hear me?
Yeah, maybe false flag, false flag.
False flag. Whoever can't hear on YouTube, you could go on X. X is on a little bit more of a delay. So you could try it out, but it looks good? Okay. All right. Yeah, okay. So we're not going to be focusing on those massive models. It's a whole different discussion. That's more a comparison of, ability to think and solve complex tasks with the, closed source frontier models coming out of the labs. We're going to be focusing more on these small open source models. These come out pretty frequently. They don't have as much noise around them. Although, you see a lot of posts like companies like Cursor, LangChain, Harvey, they come out and saying like, hey, we have a task-specific LLM model that's better than GPT or better than so on and so forth, specifically for our use case. So we're talking about those classes of models. And the question that we want to answer is, does this make sense for you? Let's say you being a team who's building a production AI application, you have users, you're using a platform like PromptLayer, and the question is should we use a open source model in order to reduce costs and cut latency? Is it worth our time? Will it reduce costs? And how will it affect our accuracy? So that's what we're focusing on today. And we're going to dive in with two practical examples. And we're going to discuss, as I mentioned, when it does make sense and when it does not make sense. So there we go. This is just a framing for the webinar. And another framing slide. When is it worthwhile to move off of these frontier models to an open source small model? Oh, and another thing to keep in mind is like, why is this relevant? Like, why are we speaking about it? So one, there's obviously the cost and the latency. Also, the question is it is a little bit overkill. Oftentimes, we see a lot of our customers performing very simple tasks, and they'll use a more expensive model because while the task is pretty simple, the accuracy is the main thing that they care about. So they're using a model, a frontier, close to 1 trillion or more than 1 trillion parameter model. Those models take about 8 GPUs or if not more to run in production. And we're going to ask the question of, can you reduce that to one of these small LLM models that run on 1 GPU by using, the whole premise of this experimentation we're going to talk about is using distillation, right? So the idea would be you use a frontier model for a few weeks, you gather some production traces, use that to teach a student a much smaller model to distill it in order to save cost and latency, right, while maintaining accuracy. So again, that's exactly what I said. The premise is that you pay for the frontier model, you get a significant amount of traces or a good amount of traces, then you distill a fine-tuned small model and use that in production. So we're going to be focusing on two case studies in this webinar. One is a one-shot prompt, meaning a prompt that just takes an input, outputs an output, and that is used in the production use case. We're going to be using our LLM assertion. This is kind of a judge prompt, a prompt that takes a piece of data and a Boolean question and answers true or false on that. Then we're going to look at a much more complicated task. So on PromptLayer, we have this assertion that's used in our evaluations and soon to be elsewhere on our platform. And we also have the Wrangler AI. The Wrangler AI is a classic agentic prompt that is a prompt that loops over a bunch of tools in order to answer a question or perform actions on PromptLayer. So we're going to look at both of these, starting with LLM assertion, which is a little bit more basic, a little bit easier task, and then to something which is more common of a use case for agentic application builders, Wrangler AI. And we're going to discuss the use cases of both. So LLM assertion, the conclusion, we'll start with the conclusion, is a very clean and easy win. The prompt I could show you right here in PromptLayer is a very basic prompt. It's has a little bit of rules where we explain what to do. It takes in the assertion from the customer, takes in the data, and then it reuses a tool call to return a true false, a reason, and a citation. So a citation from the data, why something failed or why something passed from the prompt. So it's a single shot prompt. It's used in our evals product, and we currently have it running in production with GPT-5. We've iterated on it several times, and we just found that using some of the cheaper models, like the Flashes and the Nanos, don't have good enough reasoning. So we chose to use a little bit more of an expensive model in production because this is something that people use to judge and work on their evaluations. So we started with a data set of about 10,000 requests. In general, this is some of our production data from the last 14 days. In general, the input is not so big. It's about 2,000 tokens input and about 115 tokens output. The output is a tool call, very basic tool call. The cost on average, because we're using GPT-5 that's a little bit more expensive, is about 0.4 of a cent. And the latency is also a little bit high, around 3 seconds. Because we do have, I don't think we're using thinking in production, but it still does take some time to use that. So this is our production data using GPT-5. So after doing a whole variety of different experiments with different open source small models, we chose Gemma 4B as the small model to serve. We trained it on about 10,000 examples. We changed it from a tool call to a structured output. We just found that Gemma 4B was better at learning to do structured output. And then we had a holdout validation set and a evaluation set that we used to kind of see what the accuracy was. So we'll get into this in a second. I'm going to go here first, and then we're going to go backwards. So at the end, after working, using a few tricks and spending about a week or so fine-tuning, we were able to easily knock this out of the park, right? We were able to reduce both the cost and the latency while maintaining accuracy. So you could see here, the accuracy about 92% of the Gemma 4B fine-tuned model compared to what GPT-5 has in the evaluation set. And the thing I want to note is that when we ran experiments, GPT-5 only agreed with itself 95% of the time. So we have a noisy data set, right? This is using production logs. So for Gemma 4B to get close to get to 92% accuracy, I would say basically that's the same thing as GPT-5 within the error bounds, right? Because GPT-5 itself, it was around 94, 95% when you ran it over the evaluation set several times. There's some examples that probably need to be cleaned out of the evaluation set that were a little bit lossy. So again, the premise of this prompt is that it's a simple prompt where you take the rules, the prompt template, you take the assertion, you take the data that you're asserting over, and then you just output the Boolean value, the reasoning, and the citation. Very easy, very great use case. Yeah.
There is a question in chat.
Yeah.
Was the accuracy pre-distillation?
Oh, that's a good question. I don't have it here. It was in the 60s. It was very bad. It was very bad. And then also the other thing, and we'll get this more in Wrangler AI. A lot of I tried Quen, and we'll talk about more of the Wrangler AI. I tried Quen and a lot of these other smaller models. Some of them, they don't do structured output well. They don't do tool calling well unless you distill, right? Gemma 4B, just for some reason, it was super good right out of the box. It was in the 70s or 60s, something like that. I could find that after the fact. And it was good at adhering to the tool calls. So that was good. So I think one of the conclusions, and we'll get this towards the end, is that if you have a single shot task, or maybe a linear task with a few prompts, that's even sophisticated, right? Because LLM assertion, there is some subtlety to it, right? You need to analyze the text and determine if it's true or false. You could easily do it. We're going to talk towards the conclusions of like what would be the metric, in terms of spend, of how much you're spending in order to make it make sense, and how many traces you need. but definitely doable. Now, to get into the details of what we did to get the latency down, there's something called speculative decoding. So we not only distilled, but we also distilled the speculative decoding head on top of the model. So this is kind of a trick that everybody's using nowadays. In fact, if you start doing research online, it's a little bit hard because there are 3 or 4 models that you could use to serve these LLMs. And then there are like 5 or 6 different speculative decoding mechanisms. Like for example, there's Eagle, there's like Eagle 1, Eagle 2, Eagle 3, and then there's DFlash, which is what we ended up using. Basically, I mean, not to get into the details, you could look at the blog post, you could look at the things about this. This is moving very, very quickly, and you'll often find if you do dive into this, a lot of these like research papers or like, ZAI or, one of these other open source people that figure, or, some university that has this new way to train or new way to speculative decoding is not supported at all, right, amongst all the different training and serving libraries. So obviously with like AI, I just had Claude in the loop patching all these libraries manually for the training, which is one other side note that I'll get to towards the end. It was very, 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 very hacky, but there are like hundreds of different mechanisms to do this, and it's like kind of the Wild West. So basically Eagle and DFlash came out 6 months ago. What they do is that they train a much smaller model to predict more than one token. So you have the 4 billion parameter gamma model that predicts the next token. That's like the smart, powerful model. And then you have a very, very, very small model that tries to predict, up to, let's say, 12 tokens after that, right? The idea is that if you're doing something that's like a very use case specific prompt, so for example, an LLM assertion is either a tool call or structured output, is what we finalize on. When you see specific tokens, the probability that the next token will be, something similar is very high. So for example, when you see squiggly bracket open, it's going to be new line, and then, oh, I need to move a little bit. Thank you, Will. That was a little bit like kind of, yeah. When you see the squiggly bracket, you know that you could kind of jump, right? Because immediately it's going to be the new line in the key. Or in the name of the tool call, when you see the start of the tool call, you could kind of, you don't have to pass through the 4 billion parameter model and get the full name of the tool call. You could just skip it using speculative decoding. DFlash and Eagle, you could read the blog post what the difference between them is, but they're just like the mechanism and how they do it and the tricks that they use to make it go quicker are different. So DFlash, it got, I think, our average acceptance rate, meaning how many tokens we accept, it was about 3. So it allowed you to skip, instead of having to kind of, run the model every single token. On average, it allowed you to skip ahead 3 extra tokens. So that's pretty good. And obviously, you could use your intuition. Your mileage will vary, but probably if you're using very use case specific things, like where it's tool calls or structured output, you could probably get a lot of benefits. If you look at the blog posts about all of these, the use case they use is code, right? Code also, there's like some structure to a code, right? You have indentation tabs and stuff like that. You don't need to waste a lot of forward passes of the model in order to get all that indentation out. So these are tricks that people use to make things to go quicker, right? So again, this is just if anybody's interested, you could reach out and we could talk about this more. But kind of the journey of what we did, SGLang, VLLM, these are different serving Python libraries, right? They have different optimizations within them. Some people say one is faster than the other. Some of them support Gamma 4B, some of them don't. Some of them only support Eagle, some of them don't, right? Like DFlash this and that. Oftentimes when I hit an issue, I ask Claude to research it and someone had a PR open, right? Trying to fix the issue I was doing. So it's very, very, very early stages. A lot of iteration on this. You could get very far just putting your Claude in the loop, but it's going to be probably code that you don't understand, right? Because it's just a thing on top of a thing on top of a thing on top of a thing. In our experimentation, we hosted this on Modal. Modal's pretty good. It's very easy to use and very quick. And what that changes is it changes the mechanism of price becomes latency, because Modal charges you by like the GPU microsecond or whatever it is. It's like just the smallest level of timing on the GPU. So the faster you get it, the cheaper it becomes, right? There's also Fireworks AI and some of those other platforms. They allow you to fine tune on those platforms, and it's just like one click fine tune. Their pricing is by the token, so it's still like kind of the mechanism that you're used to with OpenAI and Anthropic. The thing is that they don't allow you to use all these tricks, right? You upload a JSON-L, they fine tune it for you, they output an endpoint, and so on and so forth. When you use modal, you could use the state-of-the-art tricks, but then there's a lot of other problems, right? Because then modal unless you want to pay for the GPU to be on all the time, it has a cold start issue. There are tricks for that as well, but there are some subtleties. But this is kind of showing you is that you're able to take GPT-5, which is close to a trillion parameter model, and get the same amount of accuracy with really, really, really good latency using VLM and DFlash only with 10,000 traces. So the idea is in production, if you're spending, let's say, a few $1,000s a month, you could cut the price down significantly if that prompt isn't changing so much. And even if it is, if you have high throughput of traffic with a one-shot prompt, easily you could do it yourself. And we'll talk about the mechanisms of when it makes sense and when it doesn't. So again, summary is single shot tasks, easy win. Today, state of the art. You don't really need to be sweat so much over it. You could easily get it done. It really has to be though make sense economically, which we'll talk about at the end. Again, so yeah, these are some of the costs and latencies, much quicker. Oh, and then I'll just show an example. So this is our LM assertion prompt. Here I ran it earlier. I gave it a simple data example of a JSON, and I said, is this a valid JSON blob, right? GPT-5 is using the tool call. It was about 8 seconds it took it. This is on our playground, so it uses streaming and stuff like that, so the timing's a little bit higher. And obviously it says it's not a valid JSON. It gives the citation and it gives the reasoning. And then I took the same example and I put it on the same prompt, just the JSON version, with the Gamma 4B fine-tune model on modal. And you see we have 2 seconds, and this is coherent. This is 100% coherent. The missing comma between world and goodbye or unquoted by goodbye causes invalidity, and the reasoning and the citation is all there, right? So again, it would be whoever suggested in the comments to show what it would look like without distillation. It wasn't this, but you're able to get this pretty quickly, pretty easily, and the price and latency is reduced, right? And there's also a further discussion where I'm not sure if this makes sense, but if accuracy is a main concern, you could even improve accuracy if you had a human or an even more expensive model go over the training data, the 10,000 traces that you use to distill and remove examples. But that gets into, again, a discussion of when does that make sense for a team, when does that make sense for a company, right? So, all right, that's we have the LM assertion. Very simple, easy, great use case, surprising results. Is it worth it? Depends on how much you spend in LLMs and how much you care about cost and latency. Now let's go to the more hard one. and this one's a lot more difficult and it took, it's a lot more research. So Wrangler AI, it's a very simple agent, I would say, in that it's not super optimized, right? And I'll explain what I mean by that. But we have this prompt here. This is it in PromptLayer. It is the prompt that we use for this AI assistant that we have. It's currently using Opus 4.7 in production. It is a massive prompt with a massive amount of instructions. I think it's like about 60,000 input tokens on average, and goes up to about 125 in P99 tokens. I don't know if they could hear the police. They could hear the police. Some polices. We don't have soundproof windows. Something's happening outside. So this is a lot more interesting, right? We have this massive prompt. Oh, and it has 64 tools, right? So that's included in the 65,000, input. It's a massive prompt, right? So there's a lot of fundamental difficulties with this, and also it keeps on looping. So as a customer has a conversation, the context becomes bigger and bigger. This anecdotally works really well on our platform. We're actually releasing, and maybe towards the end I'll demo it, a lot of agent evaluation tools that we could use to show that it's doing better, that we use to compare. I'll show in a second that we used to compare with the fine-tuned model that we got. But this works well. It's just expensive, right? And these types of use cases, at least internally at PromptLayer, we don't care. We're not so sensitive to the latency here because it's a tool customers using a chatbot and it's not that bad. But the cost is expensive. Like an average customer question that a customer sends us is about $1. It's very high. The spans are massive, right? And the latency is also high in 11 seconds. The turn is not just the LLM calls. It means like calling all the tools and whatnot. So that gets very high, right? So this, as you can see, is a much more complicated use case, right? So their task itself already from the first hour that we tried to fine tune this has some issues. First of all, it doesn't fit on a GPU, right? It was very difficult to train like a full, even before that, we don't have as many traces, right? We had for this use case about 2,000 traces to train on, which is not that much. And those were also across different versions of a prompt, which I'll explain in a second. It makes it a little bit complicated. So first thing is that, the Gamma models, not to get into the details, they use some form of attention that uses a lot more memory, right? It's like a non-linear attention. You could ignore that, but basically what that means is that when you put in input, as you put more tokens in the input, it's not a linear amount of RAM, it takes a lot more RAM. So you can't fit training examples like beyond 60K tokens on like the A100 or whatever we were using, right? So we had to do a handful of things already from the get-go to get this even to fit in the context, right? And train on the model, right? If you recall, the LLM assertion prompt, the average input token was 2,000, right? This one, the average is 60K, right? So it's a lot bigger. So what we did, just as a proof of concept, let me see if I opened it up here. We trained it on an empty prompt, right? Just a diff of what the production prompt was, where is the variables that are changing, right? So I mean, if I show you this side by side, we took out all that context, right? Which again is not ideal, right? But we just wanted to see how far we could get. So we took out all of these rules that are constant, and the idea was that by using distillation, the model will learn the rules, right? And to some extent it did. And we'll show you what the failure modes were with this one. The TLDRs just didn't really work so well, and we'll get into that. So what we did is we removed all the context. We didn't run this experiment, but we were going to run another experiment where instead of giving all 64 tools, to only give about 20 of the most common, probably 20 of the most common is like 90% of the traces, if not more. I know a lot of more teams that are, have higher use agents, they are dynamically loading tools and dynamically loading sections of the prompt, so they probably don't have as severe of an issue as we do, right? Because otherwise, this is kind of cost prohibitive, the way that we designed this if we were doing like millions of requests a day. So we tried a lot of tricks like this, and the one that we settled on was, let's just, reduce the training examples to only small questions and small prompt iterations, and also remove the prompt. So basically the training data that we used was, in PromptLayer is a concept of a placeholder, so it's like each request that we use is a different point in time in a conversation, and we just took all the ones that were below 64,000 tokens as an input and used that as part of the training data. Let me see if there's anything else relevant in there. Again, we couldn't get Gamma 4B to work for this webinar. We had to use a Quen model, Quen 3.5. I think we used their 9 billion parameter model. That was able to be trained using modal. Again, you had to do a lot of hacks, a lot of tricks, and so on and so forth. So yeah, again, this was a lot more difficult than the LLM assertion one because of the context window and also because of the complexity of the task. So, all right, these are the models we tried: Gamma 3.54b, 9b, not Gamma, Quen, and then Quen 3. Quen 3 wasn't so good. Gamma 12b we tried as well. I don't think we finally got the training run to finish on that. And the best result we got was actually pretty good, but I'll explain why in reality it isn't so good. We got after we distilled the Gamma 3.59b model, 82% of the time it would predict the right tool call from the evaluation data set. So again, try to visualize here. We have a data set that's like a bunch of different frozen steps in time as part of this Wrangler, this AI loop, this agent loop. And after fine tuning, 82% of the time, the name was correct, right? And then we also did some mechanism on you know, the values and the arguments and so on and so forth. And I'll show you some examples. But really, at the end of the day, it was able to predict the correct next tool, right? Not extremely high accuracy. We could probably get a little bit more juice out of there, but that's what we did. And by the way, we used the supervised fine tuning. We tried some of these other tricks. Supervised fine tuning is literally you just compared the exact output the production trace has with the output that you had. So it's not like we rewarded the model for having the correct tool name more than, you know, having a correct reasoning, because you can make the argument that the reasoning doesn't really matter. You don't really care about the reasoning. You care about the tool name and the values. We tried that. It was a little bit more difficult to get that to work well. Instead, we just did basic supervised fine tuning, compare the output to the output, right? Again, you know, this is what we got. The tool name accuracy was pretty high on the 3.5 models. Is interestingly enough, 4B and 9B were about the same, but it was the full trajectory that was more problematic. So let's show you a little bit more of kind of what happened. So I want to show another trace, this trace. So this was the first. We did 2 fine-tuned models here. This is the first fine-tuned Quen model that we had, and we ran a simple, you know, example question where we said show recent requests that return an error. So whenever we send a question, we also send it with the URL that the customer is on the page for. In this case, I don't know if it was intentionally or unintentionally, we didn't pass in the URL, but this just demonstrates how dumb this model is. Even though we fine-tuned it, like you could see that it has just really, really bad knowledge capability, right? So you see here, it has no URL. So what it should do, and we could try to do this live, rerun it and on what it would do in a production Wrangler AI, but it starts hallucinating the workspace ID. So it says workspace ID 1. That's not the workspace ID because no workspace ID was given. Then the tool gives the error, gives the error that, you know, this is not the workspace ID that you're in. So instead of like coming back and telling the customer, hey, you know, as it should in this chatbot scenario, is to say, hey, I don't have a workspace ID. I can't run this request. Instead, it just starts doing a lot of other things. So you could see it is making correct tool calls as we fine-tuned it, right? We fine-tuned it to be able to create tool calls, and you could see that it sees that it learned from the training data that when one request doesn't work, because sometimes we have tool failures, it tries a similar other tool, but it doesn't realize the core problem that it doesn't have access to the workspace, right? And now you see it's hallucinating random workspace IDs and so on and so forth. So this is when we realize that the Wrangler AI use case is a lot more complicated, right? This agent in a loop is a little bit more sophisticated. So we only had enough time to do one trick on this that did not work. It actually kind of screwed it up in a very bizarre way, where we augmented the data set to have basically what we did is, like, you know, Claude created a little regular expression where it looked at our training data set, and any entity that was like underscore ID, it would just create a few examples with a different ID in it. So in the training data, it would look for the same requests with a specific workspace ID and just like find and replace the workspace ID and create a few examples. Idea being to train the model never to touch the ID, right? But that didn't work, right? So you can see this is one common failure mode with this fine-tuned model, is that it is, to some extent, it is making the tool calls, right? And in basic questions, it does an okay job, right? So that 82% name recognition, it's like tool call recognition. It is working, right? But it's just, it doesn't have that strength and knowledge, right, that we needed. Let me see if I have another example that I could show you guys. This one, again, another example, it just keeps on going in loops and is not able to, you see, it just keeps on calling the same tool. This one, actually, I'm not entirely sure why it failed, but it was, I don't know if you know, Vlad.
Yeah,
But
it started creating just tools.
but it wasn't supposed to create tools.
Yeah, it was creating tools, 61 tool.
Yeah. So yeah, 612. It wasn't doing well with large context. Basically, what we found with the Quen, and if I had time, was trying to figure out a way to train on Gemma. It was very difficult. None of the libraries were able to train on Gemma with large context. But this, like, you ask it, and maybe we could show an example, but you ask it like a simple question, create me a prompt, it could do it, right? Like a one-shotter, right? Or like a two-shotter. But like, a lot of our customers, is like multiple steps, asking questions to do multiple things. It started, going crazy, right? And the way it was crazy is not something that's like easy identifiable in, let's say, a loss function, right? Because a loss function, you're just looking at like, let's say the output, or maybe if you want to use one of these RL type loss functions where it's like, okay, is the values correct? It was more something that was the trajectory. Just the trajectory would go completely far off in like weird failure modes, where if something was kind of out of the distribution of the training data, it would just just go crazy. So let me see what else I have open here. Okay, so this is an evaluation we did. Let me just it's another evaluation. We've got a way to these things here. Okay, so this is sorry, just refresh that page. Let me look at this one. So this evaluation we did was the new features, unreleased feature. PromptLayer should be out this week, where we used our agent evaluator, where we have an expected trajectory. So our data set includes an expected trajectory for the LLM. So, okay, it needs to use the create prompt tool. And then we look at the outputted trace. I think my computer's upset right now. But basically the idea is that, let me just refresh the page. Nope. The idea is that we took about 100 or so questions. We knew what tools we expect to be in expected trace. We ran it through the system, and the fine-tuned model, only less than 50% of the time, it used the expected tools. A lot of similar examples of what I described, where the failure mode, it was just doing the wrong thing. Now, if you look at the production original one, about 98% of the time, it did the right thing, right? So even though we had that 82% tool call match, in the long run, the whole trajectory was just off, right? And I'd assume it's just because the Quen model is just too, it's not smart enough, right? It doesn't have enough context. Would more training data be able to solve that? I'm kind of doubtful. Would a different training mechanism be able to solve that? Also kind of doubtful, because I think that just gives you a little bit more juice. Now, if you have a use case, right, where your agent is not as sophisticated, not as complicated, it's not as deep as ours was, and not that much input tokens, then yeah, this would work. I mean, it's able to learn the tools and able to do a few turns, right? But once you get like kind of the very basic first pass agent that needs large context, needs all these tools, it did not work. Is there opportunity with Gemma? Absolutely, because we found, Quen didn't do well on the LM assertion prompt. Didn't do well at all, actually. So Gamma just seems to be a far smarter model with their architecture and how they trained it. Just it was impossible for us in like a week exploration to get Gamma to train. It was just a lot of bugs, a lot of issues, and you would literally have to go in there and patch a lot of these libraries yourself. I tried it with AI like overnight in a loop. It didn't work, right? It didn't work at all, right? So I think it's like one of those tasks where you could throw a bunch of more AIs on it, but might you probably need to look into it a little bit more. Another, let me see if I could find there a few other interesting use cases. This is another feature that agent evaluation feature that we're releasing this week, where you could mock tool calls. This is not on production yet, but the idea is that in PromptLayer you have this mock tool response functionality, and you could I was going to demonstrate it, but this model is so bad that when I ask it to create a simple prompt to summarize a transcript, you see it's hallucinating. It doesn't give a tool call, but this functionality allows you to mock the tool response by giving it an output schema, right? So again, you see here, this is the prompt where we fine-tuned away the system message, and it's just this augmented model that I'm testing is the one that I did with the IDs. That ruined everything. As you can see, it can't even make a tool. So here's another one. It became very, very verbose after we fine-tuned it a second time. So again, these like more complicated tasks it's not so simple. Can you get it done? Maybe, but it's not as easy as the first use case, right? Another failure mode that we have, I might have a tab open for it here, is that sometimes it outputted malformed text. Sorry, this is not, let me show you here. You see this tool call, it started it correctly and then it just ended in the end. You could probably fine tune these types of problems away, but the large trajectory type issue that we demonstrated earlier, I don't think that's so easy with at least these 9 billion parameter coin models. By the way, as a heuristic, you could probably fit like these up to 12 billion parameter models on one GPU. Once you go above that, it becomes a little bit more complicated, right? Okay, so that's that in action. So now we're moving to the conclusion side of things, right? Which basically in this Wrangler AI use case, which is like a agentic use case that has large context windows, probably not worth it. Unless you're spending, I would, if you want a heuristic, I would say in the tens of thousands of dollars for this AI assistant, where it could kind of pay for at least an engineer or two engineers in order to manage this, right? Because this is a full management type task. Is it possible? Yes, depending on the complexity, depending on the use case, but I don't know if it's necessarily the right investment for a team's time today. Do I believe in the future it will be? Yeah, probably. I think the amount of GPUs that are required today for production AI use cases of somewhat medium to simple tasks is overkill, right? And it's just like more sustainable to have these fine-tuned models on there. But I think today, if you have a one-shot task, it's very doable. Here's the kind of the conclusion decision framework, right? If you have a one-shot task, it's honestly, if you're spending at least $1,000, $2,000 a month on that prompt, very much worth it. Because it's not that complicated, and the accuracy is maintained, and it's both faster and cost-effective, right? If you have an agentic tool loop, you need to be, spending at least the tens of thousands of dollars a month to do it, to even, I think, consider it. And you need to kind of have a much more bespoke solution in order to get that done. Okay, this is just basically some slides that demonstrate when it makes sense and when it doesn't make sense. And then kind of on PromptLayer, the way we're thinking about this, why we're considering this, is that we wanted to just see what the state of the art is, keep ourselves updated, keep ourselves up to date with what's going on, help educate our customers, help determine whether or not this is time to do build additional functionality on PromptLayer to enable, as you create new versions of the prompt, automatic fine tune and whatnot. Right now, we're not entirely sure where we're going to go with this functionality, but if there's anybody in the audience or anybody who's listening to this who is curious exploring this in some form of POC or at least doing some knowledge transfer, please reach out. We definitely I spent about 2 weeks on this doing a lot of research and whatnot, so could help, and we could potentially help build something out for you as well if there is interest and you're currently using PromptLayer. But one core point is like the importance of maintaining your traces and keeping your traces, because there is value in them, especially if you are a high payer to OpenAI or Anthropic or one of these model providers. If you're spending in the hundreds of thousands or millions of dollars a year, that is potentially something that you could easily halve, right? Depending on your use case, either within a week you could halve, or if you're doing a more agentic thing and you're spending in the hundreds of thousands, it's definitely worth exploring at that point. And you could probably, if not half, easily reduce 10%, 25%, 30% by switching to the open source models. Yeah, so that's basically the presentation. Quickly ran through a lot of things. There's a lot of technical details and questions in there. I'm happy to answer any questions if there's anybody who has them. We're have about like 10 minutes or so to do that. Anything in the... Okay, we could give it a minute. But yeah, I mean, happy to see if anybody kind of has any thoughts to share or anything, if this was interesting to them or something that they're considering. Happy to continue the conversation over email or you could reach out at john@promptlayer.com, jon@promptlayer.com, or just on our Discord or intercom on our platform or anywhere else you could find us. Okay. All right, so you want to stop the stream on the thing? Oh, yeah. Get us